Hey guys, this is Mrs. Gebhardt and we are on study guide video number 2. Okay, this video is a little bit different because I wanted to show you guys some stuff and it was really hard to show you the other way, so I decided to do a video this way. If you look up here, we have the video on water properties, and the video is also going to be on water quality indicators, and these are going to be questions 1 and then 10 through 13. So please make sure you look at those questions. So let's look at question number 1. Question number 1 is going to be a couple slides long, but it's actually going through the different water properties. So let's start with cohesion, okay? So we know cohesion is water sticking to water, okay? And I'm going to step out of the camera for 1 second, but I want you to imagine Mr. Water Droplet, smiley face right here. And there's a second water droplet, and they're attracted to each other. Okay, so water sticking to water, cohesion. Okay, adhesion is, think of like adhesive tape. It's sticking to something else. So I drew myself a little umbrella. Okay, so my little umbrella's going on right here. Water dropping down from the sky, bloop, 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 sticking to something else like an umbrella. This is adhesion. So water sticking to something else, okay? All right, let's go to the next one. So specific heat, and I want you to envision specific heat. I want you to think about the beach, because the beach is probably the best example of explaining it. When we go to the beach, let's say we go to the beach and it's March. If I go to the beach in March, the temperature outside might feel pretty comfortable. We might be wearing flip-flops, we might be able to play in the sand, wearing shorts and stuff like that. But if we go into the water is not likely as warm. All right, but if I go in July or August, the water temperature is really, really warm. That's because water has a very high specific heat. So very high specific heat takes a tremendous amount of energy to heat that water up. But once it's heated up, it stays warm for a pretty decent amount of time. That's why you could go to the beach in September or October and the water's still not that bad feeling, okay, because it has high specific heat. Because of this, it'll help to cool things down. So we might see water circulating around a pipe in order to help cool that pipe down, okay? The next one is density and then polarity. So we'll do density first. Okay, so density, I'm going to show you a little demonstration. Okay, I've got a glass of water. I'll put this in the lid. So you see my glass of water. Okay, and I've got an ice cube. All right, we all know it's probably going to happen when I put that ice cube in the water. I'll get it close to the camera. Notice that the ice cube floats. The ice cube floats because the ice cube is less dense than the liquid water that it's in. So that's density. And putting it in a mathematical sense, it's the amount of matter in a given volume. But when we think of it in terms of water, it's going to tell us that certain objects are more or less dense in water. So obviously the ice cube, as we can see, is less dense than the glass of water, and there's my ice cube right there. Other things are going to be more dense. If I put a rock in there, it's going to fall all the way down, okay? Density is also going to be affected by salt, so keep that in mind. We'll talk about salts later, but that's going to have an effect on it as well. Polarity, think of a magnet. So I've got positive and I've got negative ends. Water is a very attractive molecule. It gets along really well with a lot of stuff. Like sugar, it gets along with salts, it gets along with hot cocoa, it gets along with a lot of things, it mixes with it. And that's because of this attractiveness, okay? So it's able to kind of go out and seek other things out and attach to it and dissolve them, okay? All right, and then the last thing is surface tension, and we should think about surface tension when we think about a little buggy walking on water, okay? But when we think about surface tension, we have a surface that's created, okay? And with that surface, it's so tense that all I have to do is break that surface and a bug could fall in, because a bug should be or is more dense than the water, but because of surface tension, that bug is able to actually be on top of the water. You guys did this with the paper clip. So the paper clip floated on water because it was able to sit on that water because of the surface tension. All we had to do was break the tension and the paper clip fell. Okay. All right, question number 10 is asking about bioindicators and macroinvertebrates, okay? And I don't want this term right here to scare you. A macroinvertebrate is simply a large bug. Think of it like a large bug, Okay, an invertebrate is a critter that doesn't have a backbone. So, like, for example, as gross as it sounds, is like a cockroach. A cockroach doesn't have a backbone. It's got an exoskeleton, so when you squish a cockroach, it goes crunch, but it doesn't have like a back. We have a backbone, that vertebrae back there. So we're thinking about a large bug. Could be bugs, could be something shrimp-like, and these are called bioindicators, and their presence and a tremendous amount of them and a diverse amount of them. So if we have all different kinds of bugs and little critters with, all these little macroinvertebrates, tells us that a body of water is healthy. So if I was going up on a lake or a stream or something and I saw a ton of this stuff, I could assume that the body of water is healthy. If I come up on a pond and I don't see anything, and I know I should see something, I can assume that this body of water is disgusting. And this is before I've even actually taken a sample and tested it. Okay, so that's a bioindicator, and that's a macroinvertebrate. All right, pH. And this is something else that we can do to test water quality. pH is just a measurement of something that's an acid or a base. So I've got an example. This is a nice little, these are actually one of these little cuties, clementines things. But if I were to take this and I were to cut it open and I were to cut myself and squeeze it on that cut, it would burn. Okay, because this is an acid. You've got acids in your tummy. You know, if you've ever gotten sick and it came out your nose kind of burned, or your throat might burn or whatever, that's an acid. Okay, an example of a base. Voila! This is a good old carton of, you guessed it, there it is, milk. Okay, this is a base, all right? So all it is when we say a pH, we're just measuring how much of an acid it is, or how much of a base it is. Now when I look at pH, anything that is less than 7, so less than 7 is considered an acid. Anything over 7 is considered a base. Anything that falls directly at 7, that is neutral, and that would be what a little fishy would like to live in. A fishy doesn't want to live in this, and a fishy really doesn't want to live too much in this. A fishy wants to live in an environment that is neutral, that there's not going to be any kind of stinging or anything going on. And an acid or a base, depending on how strong it is, could make that type of environment. All right, turbidity. So turbidity is clarity, okay? And you can see, I'm going to do 2 examples here, so hold on for the noise. Sorry about that. I'm dumping some ice out. But here is a glass of water. Turbidity is clarity. So you know that you can, I know it's hard to see, but you can kind of, you can see, look close, you can see my hand through this. I mean, this is clear as can be. You can see right through it. Put my face right on it. Okay, clarity. If I were then to take and look at milk instead, okay, so I'm going to pour some milk, good old glass of milk, all right, I can put this up here, but you're not seeing through it, okay? This is highly turbid, or has a high turbidity, and what this does is this causes the water to be really yucky and therefore not able to let the sunlight get through, and the plants that are in the actual pond do what they need to do. This is going to often be caused by high urban runoff, and urban runoff is going to be anything that drains out of your car, any fertilizers or pesticides that you may put on your lawn. You wash your car, any of that. It's going to drain down your driveway and it's going to go into the water, and it can get to a river or a lake, and this could lead to turbidity. Okay. All right, the next question is talking about dissolved oxygen. This isn't too hard. It literally is how much oxygen is dissolved in the water. Obviously, if you're the little fishy, you need the oxygen to breathe. Okay, so that's something very essential. But dissolved oxygen, just the amount of oxygen. This is dependent on temperature. So if it's colder temperatures will hold a little more oxygen than warmer temperatures. So right up at the very tip top of the surface of the lake or something is going to be warm. Probably not going to be as much in terms of oxygen as it would if you got a little bit deeper and it got a little bit cooler. And that is it for this video, smiley face. So please tune in to the next video so that you can get the next set of questions. And if you have any questions, please make sure you ask your teacher.